All right, so now let's move now to question 2, which is the next slide. Question 2, obviously, we have been given an acid, H2SO4, which is tetrahydrosulfate 6 acid. Never call it sulfuric acid. And our B is NaOH, as sodium hydroxide. So from what we can see in our question, our A is standard. A is 0.103 mole per dm cube. Standard solution simply means a solution of known concentration. So since we know the concentration of A, it simply means that A is what? A is standard. Now, you look at B. B is a saturated solution of NaOH at room temperature. We are now given the concentration of B. It simply means that B is not standard, for the record. Now, our first question now says, calculate the solubility of B in mole per dm cube for I gram per dm cube. Obviously, then you have what volume of distilled water must be added. So 500 cm cube of B in order to reduce the concentration of Na plus ions to 1/4 of its original value. So you've been given the chemical balance equation there as H2SO4 plus 2 NaOH, giving you Na2SO4 plus 2H2O. Now, the mole ratio for acid is 1 because the coefficient of the acid is 1. The mole ratio of the base is 2 because the coefficient of the base is what? 2. So Na is what? 23. O is what? 16. H is what? 1. Now, if you look at our solution, the fourth question says, let's find the solubility of NaOH in mole per dm cube. In this case, we are not dissolving anything in anything. Like nothing is being dissolved in any solvent. So it simply means that the solubility at this point will be the concentration. If you look at it carefully, they are the same units, gram per dm cube, mole per dm cube, both solubility and concentration. So the solubility of B in mole per dm cube now has its own formula. The formula is obviously the concentration of what? Of B in mole per dm cube. But because B itself is not being given in any standard way, we don't know the solution. That's why we should use the dilution for acid or for acid and base, which is CAVA over CBVB equals to Na over NB. Now, it is very paramount, so vital, that you write the mole ratio of the acid to the base. So our Na is 1, our NB is 2. How do we get that? Na is the coefficient of the acid from the balanced equation, while NB is the coefficient of the base from the balanced equation. So looking at it, CB is equals to CAVA NB over VB Na. That's when we make CB the subject of the formula. So our correct substitution, substituting the right value, which is also 1 mark, is very important because you don't have to jump that step. So that is, you introduce them 0.103 times 12.20 times 2. Now, mind you, I am using 12.20 because that's the value I want to use for my title value. The VB, volume of the base, is your volume of your pipette. You can decide to use 20.0 cm cube. You can decide to use 25.0 cm cube. But I am sure that we West Africans, we always use 25.0 centimeter cube. So, proceeding past that, our CB from everything here will be 0.101 mole per dm cube. It is very important that your answer must be in 3 significant figures. Very, very important. So now that we have the solubility of NaOH in mole per dm cube, it is very easy for us to get it in gram per dm cube. How do we go about it? We say solubility in gram per dm cube will be equal to solubility in mole per dm cube multiplied by the molar mass of the NaOH. So never solve the molar mass of the NaOH separately. It's part of the mark. Show how you got the molar mass of what? NaOH. And the molar mass of NaOH is when we add their relative atomic masses together. Mind you, you'll be given their relative atomic mass of each element. So Na is 23, O is 16, H is 1. So that will probably give us 40 gram per mole. So our solubility in gram per dm cube will be 0.101 multiplied by 40, which should be equal to 4.04 gram per dm cube. Now, if you look at the other side, the B, it said we should find the what? Find the volume of water that will be added. There's a law around volume of water added in dilution. We know that C1 V1 is equal to C2 V2. C1 is our initial concentration, V1 is our initial volume. C2 is our final concentration, V2 is our final volume. Now, your C has to be in mole per dm cube, never in gram per dm cube. So luckily for us, that's how we are going to work around it. So if you look at V2, V2 is the V1 plus the volume of water that was added. So that means that volume of water added would be equals to V2 minus V1. Now, when NaOH, when it ionizes, it will give you Na plus and OH minus. That is, the NaOH and the Na plus, they will have a mole ratio of 1 to 1. It simply means whatever your mole for NaOH is, that will be your mole for Na plus. Whatever your concentration for NaOH, that will also be your conc for what? Na plus. So, in the question it says, what volume of distilled water must be added to 500 cm cube of B? That means the initial volume of B is 500 cm cube. That means your V1 is 500 cm cube. So, what volume of water that will be added? That means we are looking for V2 minus V1, obviously, to reduce the concentration of Na plus to 1/4 of its ion. It simply means that if my initial conc is 1, my new conc will be 1/4. So that's where we derived if our C1 is 1, our C2 will be what? 1/4. Because our concentration has been 1/4. That means it has been reduced by 1/4. That's why C1 is 1 and C2 is 1/4. So what will be V2? So applying the formula, you make V2 the subject of the formula. V2 will be C1 V1 over C2. So if I do everything, that will be 1 times 500 divided by 1/4. So our V2 will give us 2000 centimeter cube. Then what will be the volume of water added? Volume of water added, which I said earlier, V2 minus V1, would be equals to 2000 minus 500. So that will give us 1500 centimeter cube. So that is all these answers for question 2.